Hello everyone. Today we are going to solve a new problem, spiral matrix. Given an M cross N matrix, return all the elements of the matrix in spiral order. We have an example 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have to just walk through this matrix in spiral order and return that order. Okay, let's understand how we can solve this problem. We'll use the same matrix example 1, 2, 3, 4, 5, 6, 7, 8, 9. The easiest way to solve this problem is to do exactly what is asked in the question. We are just going to iterate through this matrix in spiral order and we'll keep on printing or capturing what that item is, and we are just going to return it. Right, so we'll first go through the first row, then last column, then last row, and then first column, and then we basically have kind of captured the outermost layer and we keep on doing it. Okay, sure. What we can do is we keep a variable row min, row max, and column min, column max. I should write row max below this. Row min in the beginning is going to start at 0 and row max will start at the end. Column min, so this is row min to row max, and in our matrix we are going to have this as column min, the minimum column, and this is maximum column, and we can just iterate from minimum column to maximum column of the row min as the first kind of first few items of that list. Then because we have iterated through this, we have captured all of the items in row min, we can extend the row min, we can increase it by +1. Okay, it'll be helpful once we complete the spiral, complete the outermost layer, and we start again instead of starting from index 0, because when let's say we complete this outermost layer, we would want to start again from this one, right? Okay, one row below row min. So when we complete this iteration, we extend row min by 1. When we complete this iteration, that means we have walked through column max, so we reduce column max by 1. Why? Because once we complete the first spiral, in the second spiral, that is one layer below the first spiral, we go through row is equal to 1 because we extended row min by 1, and then we have to go through column max -1. Okay, so this is the inner layer. Once we complete the inner layer, we'll have another layer, and we keep on walking through this matrix from outer to inner to inner to inner, kind of like peeling the onion layers. Okay, so let's solve this. So we keep a row min that starts from 0, the minimum row, and row max, that is going to be matrix length -1. Column min is going to start at 0 and column max is going to start at because all of the rows will have same number of columns, this, and then we just walk through this matrix in spiral order. Let's add some validation. Row min needs to be less than equal to row max, and column min needs to be less than equal to column max. Now we are going to do a horizontal top traversal. So any layer, so layer 0 is outermost layer. Let me change the color. Layer 0 is outermost layer, then layer 1 is one layer below this. So in any layer we'll have 4 components: top, down, left, and right. So we'll do top iteration first. For top iteration, we have to move from column minimum to column maximum, right? So we do column minimum is less than equal to column maximum I plus plus, and at every cell the index would be, we are currently at row min, so row min, and our column keeps on changing from column min to column max, that is I. So this is our element. That's, we have to return list of int the spiral or order elements. So this is output, so new list of int. Okay, so this is our output. Now we'll keep on adding all of these elements whichever we encounter when we are walking through it, the matrix in spiral order. Okay, so we have walked through the top. Now we are done with, in the layer 0 or the initial layer, the top part we have iterated through that. Then we can extend the row min by 1. So we do row min plus plus. Now we'll do, we have walked through top, we'll do right for int I is equal to, for right traversal we have to start from row min and go up till row max. Yep. And okay, so the thing is, let me clear this up. If let's say we have a 3 cross 3 matrix, so in first traversal we covered these 3 cells. In the next traversal we would need to cover these two, because this was already covered, right, in this top execution. And row min plus plus is going to help, because what we are doing is we are going to traverse from row min till row max, and because row min is not 0, after top traversal it has moved to 1. Okay, so we'll do row min is less than equal to row max I plus plus, output dot add matrix. What is row? Row keeps on changing, it is I, right? And column, what is column? It is the last column, so column max. Okay, so we have now traversed through, we have walked through these two items. Now we should reduce the column max by 1. It is going to help us start our next execution from this point. That's one. And second is, once we complete this layer 0, the outermost layer, in the inner layer we'll basically, yeah, we will have column max reduced by 1, row max increased by 1, those things. Okay, so we do column max minus minus. So we have done right. Now we do bottom. For bottom we have to traverse from this end to this end. I is equal to column max, I is greater than equal to column min, and I minus minus, because we are going from right to left. And we do output dot add matrix row. Row stays same here. In the bottom part, row is always going to be row max, and column moves. So column is this. And once we have completed our bottom part, we move the row max up by 1, row max minus minus, and then we are left with left. For left we'll traverse through rows, right, from row max till row min. Output dot add matrix row is varying, and column is column min. Okay, and once we have completed the left part, we have to do column max plus plus, because we have, right, because in this matrix we just completed this part. So in the outermost layer. So in the inner layer, we would have to, for the same execution of the left part, okay, we would have to do column column min plus plus. Yep, column min plus plus. Okay, so in this way we have traversed through this matrix in the spiral order. Okay, currently we've just done one spiral motion. Okay, now this boundary condition, because for every type of execution, whether it is top, right, bottom, or down, we are increasing the row or reducing the column, row min, row max, column min, column max. We are changing these things, right? So at every point, this boundary condition can get violated. So instead of just checking it on a while loop, what we should do is we should probably create another function. Let me copy this. Copy. Let's create another function for this. Private pool is boundary valid. Okay, okay, and then we just return. So we would need row min, row max, column min, column max. Okay, and then we do is boundary row min, row max, column min, column max. Let's copy this, and whenever there is a change in any of the 4 parameter, let's check all of the boundaries. So here in this section, because row min increased by 1, so if boundary condition is okay, then we check this, then we do this. Similarly, if boundary condition is valid, control Z, my bad, and the bottom part as well, if the boundary condition is valid, then we would like to execute this chunk of code. We'll just repeat it 2 more times. Actually we are at the bottom now. If is boundary row min, row max, column min, column max, and then let's grab this x y. Okay, so we are done with boundary checks, and at the end, once we are out of this execution, we just return output, and that's it. We have traversed through it in the spiral order. Let's see. Is boundary does not exist. Is boundary valid? Is boundary. Out of index spiral order. Wait. Row min is less than equal to row max and column min is less than equal to column max. Understandable. Column min, column max is boundary row min, row max is boundary row max, column min, column max. Thing is, somewhere the index is incorrect. It is going out of the boundary. Row min, row max, column min, column max. So the initial boundary condition is fine. Let's check this validation. Row min is less than equal to row max and column min is less than equal to column max. This is completely fine. So the problem seems to be with the matrix. Let's double check this. If this boundary condition is valid, you enter, you do column min till column max, and you do for the row min all of these I, then increase row min by 1, then boundary check, and then row min till row max. This is going to work as row, and column is column max, and we do column max minus minus, boundary check, then bottom column max till column min. We do row is row max and column is I, fine, and then we do row max min min minus minus, and then boundary condition check, and finally row max till row min, and row is going to be I and column is going to be column min, and we do column min column min column min plus plus. Okay, so basically max minus column min plus, my bad. Okay, both the test cases have passed. Let's check the constraint of the question. Matrix length, there will always be at least one item in the matrix. Okay, and we are just doing linear iteration across this matrix. Let's submit the solution. Okay, it has passed all the test cases. Fine, so this is spiral matrix iteration. Cool, thank you.